Okay, so we've been told that we have two lines, L1 and L2, and we're told they're perpendicular to each other. We know that these 2 points are 3, 5 and negative 4, 7, which we've given A and B as the names of those 2 points, and we're told they lie on line 1. We're also told that line 2 intersects line 1 at A, and we've been asked to find the equation of line 2, giving your answer in general form, so ax plus by plus c equals 0, where a, b and c are integers. Okay, where do you think a good place to start is here then? So finding L1, so just looking at line 1. Yeah, fantastic. Okay, so just looking at L1, so consider L1, absolutely. Let's start off by finding the gradient. We've been given 2 points, naturally find the gradient, good. So okay, how do we find the gradient of these lines, of this line?
7.
Yep.
Minus 5.
Good, 7 minus 5
3 minus negative 2.
over negative 4, take away 3. Yeah? Just again, just make sure you get the order of those points right. We're calling that our second point, that our first point, so we need to be consistent. So okay, that is 2 over negative 7. So negative 2/7 is fine. Good rule of thumb when you're working with these questions, don't try and turn that into a decimal. Leave it as a fraction, okay? If you turn it into a decimal, you'll just get yourself into a whole heap of trouble and it's just going to come out as horrible answers. We always try when we write exam papers or homeworks or things like that to make the numbers as nice as physically possible, okay? So if you start getting things, horrible decimal answers, it's probably because you've gone wrong along the way somewhere, okay? So negative 2/7 is a fraction, it's okay. Alright, good. Now what? Now we've got the gradient, now what do we do?
Y minus y1
Okay,
equals bracket x minus x1.
so in other words, find the equation of line 1. Okay. You could absolutely find the equation of line 1, you're absolutely right if you're going to do that. I would be with you and use y minus y1 equals m times x minus x1. But look what we're after in the equation, in the question. We need to find the equation of line 2, okay? So, sure, if we got the equation of line 1, it's nice, it's there, but do we strictly speaking need it? What do we need from line 1?
Negative 7 over 2.
Yeah, exactly, because all we need from line 1 to find the equation of line 2 is its gradient, because we know they are perpendicular, okay? So we know, because they are perpendicular, that m1 is just going to be negative 1 over m2, okay? Just going to be negative reciprocal. So therefore, because we know the gradient of line 1, then we can say that the gradient of line 2 is just going to be, well, negative reciprocal of that. So negative becomes positive, flip it upside down, it's just going to be 7 over 2, okay? So that's all we needed from line 1, really, just its gradient. Kind of abusing it, all we just needed the gradient, didn't just need to find the equation. Now, we've got the gradient, what else do we need? To find the equation of line 2, what do we need to do now?
Is it this formula? Y
Yeah.
minus y1?
Exactly, now we've got the gradient, we've got a point that we know lies on the line because we know it intersects at A, in other words we're going to be using this point here, okay? We've got an x and y value, so therefore we should be able to find the equation. So equation of line 2, okay? So we're going to use y minus y1 equals m times x minus x1, and we're going to use the point 3,5, so and the point 3,5, and we stick it in that formula. So do you want to stick it in and then see if we get the same thing? So y minus y1, which is 5, equals m, which is 7 over 2, because that's the gradient of line 2, times by x minus 3. So I think because we need it in this form, I'm going to multiply everything by 2, get rid of the fraction. So 2y minus 10 equals 7x minus 21. Okay, and if I get it all on the same side, I get 7x minus 2y, that's going to be negative 21 plus 10, so that's going to be a negative 11, equals 0. I think that's fine.